Hey, welcome back everybody. Part 2 of Lesson 7 in Perms and Comms. So we were working on this investigation, C, and we are about to do n choose r plus n choose r plus 1. And we're using this pattern. So it would have to be, if you notice, it was 6 and 6, and then that went to a 7. So that means this has got to be n plus 1, one more than what these ones were. Okay, and now as far as the r part goes, this was 0 and 1, and we ended up with 1. So this would have to be the second one, this one here. So it would have to be r plus 1 if we kind of use the same pattern we had from before. Good. Okay, let's take a look at what the numbers in Pascal's triangle in each row add up to, because this is an important concept too. Complete the table for the sum of the numbers in each of the first rows. So some of the numbers in the first row, if you recall Pascal's triangle, I'll just put it on the screen here so we can use it. Okay, so the first row, the sum of the numbers would have been 1. Okay, and then the second row, that's this one, 1 plus 1 is 2. Third row, 1 plus 2 plus 1 is 4. Okay, so why don't you guys fill in 4, 5, and 6, and if you have to look at the previous page or above to do that, go ahead. And then see if you can write it as a power of 2. For instance, 4 is 2 squared, and write those all as powers of 2. And then we'll talk about these last two rows to fill in. So pause your video and get that table filled in. Okay, so we should have gotten these numbers, 4, 8, 16, 32. And then written as powers of 2, 1 is 2 to the 0, 2 is 2 to the 1, 8, 2 cubed, 16, 2 to the 4. Okay, now these last two rows we're not going to fill in right now, but you'll notice then if we have row 5, well, hang on. We're not going to write it in terms of, actually, yeah. So when, if we call it the n plus 1 row, you'll notice the exponent here is a 5. So this would be basically 2 to the n if you're doing the sum of the coefficients. So the sum of the numbers in the n plus 1 row is 2 to the n. That's the important thing you need to remember, where n is actually in your binomial is the exponent on your binomial. Okay, now as you recall, these numbers in Pascal's triangle are actually coefficient or combinations. So in row 5 we would have 4 choose 0, 4 choose 1, 4 choose 2, etc. So n in this case would be 4. Okay, so that means the sum of all those numbers, so that row should be 2 to the 4. Okay, now let's look at this. 6 choose 0, 6 choose 1. Our n value is 6. So the sum of all those coefficients from 0 all the way to 6 in that row of Pascal's triangle, therefore, using what we discovered in the table, would be 2 to the 6. All right, good. Complete the following statement. So, in other words, generically speaking, the sum of the combinations would be 2 to the whatever n was, and in this case n is n, so 2 to the n. All right, good job. Let's look at the next page. Okay, so this just reinforces what we just did. When n is 1, the sum of the coefficients are 1 plus 1, which is 2. When n is 2, 1 plus 2 plus 1 is 4. Okay, so just this is pretty much what we just did on the previous page. Sum is a power of 2, that'd be 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. So if the exponent is n, then, which it generically is, it would be 2 to the n. Good. So 2 to the n again. 3 sums equal to 2 to the n. Okay. So they're just reminding you again that the row can be written as combinations and therefore add up to 2 to the n. Okay, or if you hear it like this. We're going to put that to work on some examples. Okay. All right, example number 1. Determine the sum of the numbers in the 10th row. Now, if you recall, when it's the 10th row, your n value is only 9. So then the sum of the numbers in that row would be 2 to the n, which is equal to 2 to the 9. So your answer would be that, which equals 512. Determine the sum of the coefficients in the expansion of m plus n. So as long as these are just ones in front of those variables, the sum of the coefficients will be the sum of the numbers in a row of Pascal's triangle. This is your n value, so therefore your answer would be, you got it, 2 to the 12. I'm assuming you just said 12, so. Determine the value of 15, choose 0, plus 15, choose 1. So again, that's a row in Pascal's triangle, those combinations. Our n value is 15. We're going from 0, 1, 2, 3, all the way to 15. So this should add up to 2 to the 15. You guys kind of get the idea, right? Okay, so try what you think this next one would be. Okay, so you probably thought 2 to the 6, right? Because your n is 6, which is a good assumption. But if you look, 0, 1, 2, dot, 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 all the way to 5, we're missing 6, choose 6. And 6, choose 6 is equal to 1, right? Those numbers on the outside. So we'd have to subtract 1 to get our actual answer, which would be 64 minus 1, which is 63. Good job. Let's look at the next page. So we have previously done finding these different routes in a previous lesson in this unit where we had this 6 blocks and Paul and Catherine were trying to get from point A to point B, and Catherine had used the fact that we'd have to go, say we go, what would this be? 3 blocks to the right, so right, 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 and then 2 blocks down, so DD, which means it's like a 5-letter word. So 5 factorial ways of rearranging that 5-letter word, and then dividing by the repeats, 3 factorial, 2 factorial, and she had gotten this, right, which was 10 routes. Hopefully you remember that. Now, it can be done in a different way as well, and that's where Pascal's triangle comes in. So let's go down here and look at that. Okay, so let's look at this triangle here. So we're just kind of turning it a bit. This is point A up here, and we're trying to get to point B. Okay, so if you basically put your pencil on each intersection and you go, how many ways were there to get there if I was going from point A? And really, there'd only be one way, so you put a 1 there. And you can't backtrack on these ones. You have to keep getting closer to B. Okay, let's go over here. This point here, we could only come via this route here, so that would be 1 way. Okay, right here, we could only come basically this way, and since there was only 1 way to get to here, there'd only be 1 way to get to there. Okay, now this point here, we could come from this way, of which there was 1 way to get there, or this way, which where there was 1 way to get there. Notice I said or, so 1 or 1, so 1 plus 1 is going to be 2 ways to get to that point. Okay, this one here, we could only come from this way, so that was 1 way, so this will be 1 way. And then we keep going. This point here, we could come either from here, 1, or from here, 2 ways, which means we would have 3 ways to get there. This point here, we could come from this way, which was 2 ways to get to that point, or this way, 1 way to get there, so that's going to be 3 ways, 2 plus 1. This outside point, you could only come from the outside here, so 1 way. Okay, this point here, we could only come from there or from here. That would be 3 ways from there, or, so plus 3 ways from there would be 6 ways. You get the idea. Let's fill in the rest. 3 plus 1 is 4. And finally down here, 6 ways plus 4 ways is going to be 10 ways. So we got 10 ways again. How did the answers relate? Well, they turned out to be the same, didn't they? Okay. So let's put that to work on the next page. So you might have noticed, possibly, here's this pathway again reproduced here, that this is kind of what we came up with, right? But that is really a portion of Pascal's triangle, isn't it? Look at that, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, okay, which we know are combinations as well, right? So if we look at it that way, really the end result or the answer would have been 5, choose 3, right? Which is equivalent to 10. And 5, choose 3, using the NCR formula, n factorial over n minus r factorial. If that's 5, choose 3, that's equal to 5 factorial over 5 minus 3, which is 2 factorial, and then r, which is 3 factorial. Now, we had used this using 5 factorial ways to rearrange that 5-letter word. Divide by your repeats. See how that's the same thing? Isn't that cool? 5 choose 3, same as doing the repetitions on that 5-letter word. So another little connection there. Okay, example number 2. Supervisor of City Bus Department is determining how many routes there are from bus station to concert hall. So from here to here. Now, we are going to use Pascal's triangle to do this question, and then we'll do it with repetitions. Okay, and I'll walk you through this one, or you can try it actually. If you want to pause your video and see if you can get it, just note that whatever number you get here gets carried to this one and this one as well. Okay, so if you want to give that a try, go ahead, pause your video. Okay, so if you're back, I'm just going to run through these. One way to get here, one way to get there, one way, one way. Okay, this one you could come from this way or this way, so 2 ways, 3 and 4. This would be 1, and then this would be 2 plus 1, which is 3, 6, 10. And you're basically looking at the 2 previous numbers, right? Always moving closer to the concert hall. So 1 way to get here from above, 4 ways to get here from above or to the left, 3 plus 1. 6 plus 4 is 10, 20. Okay, and we just run through, and we should have ended up with 35 at this point. Now, if there were 35 ways to get to this point, then to get to this point would also be 35, because you would just come from there. And same thing down here. And 35 to get to here, because you'd have to come from the left there. 35 plus 35, 70. This one would be from 70 or 35, so 105. Down here, you could only come from above, 35, 105, and 105 plus 105, 210 ways. All right. With repetitions, you'd have to do this in 2 pieces. We'd have to use this 4 by 3 block, right, where you're going 3 rights and 4 downs. And then you'd have to do the other block, which is, so let's do this one first. That's a 7-letter word, 3 R's, 4 D's. And then this one is 2 rights and 2 downs. So that would be a 4-letter word, 2 repeats for D's and R's. The word and it's and because once we get to here, we have to still continue on. It's not you can do this part or this part. You have to do both. So multiply those. And if you try that on the calculator, we should end up with 210 ways. All right. Now example 3 is a little beyond the curriculum, but we can try it just for the sake of interest here. So we're going to use Pascal's triangle. And we actually have to use Pascal's triangle in a situation like this because, and that's what they're getting to on part B, if you have an overlapping, see how we sort of have a rectangle here overlapping and another one overlapping like that, you can't really do it with permutations. So you actually have to do one way, that kind of idea. So why don't you pause your video, see if you can get how many ways there would be to get to the football stadium using the 1, 1, 2s, all those, okay? So pause your video, please. All right, so if you got 119 ways, then you did it correctly, okay? If you want, pause the video and take a look at all these numbers and see if they're all the same if you didn't get it correct. All right, good job, you guys. You're ready to do the assignment on lesson 7. Thanks for listening, and we'll see you for our last lesson on lesson 8 next time.